Hello viewers, welcome to my YouTube channel. Today we will be solving an initial value problem using Laplace transform. So this is the equation we'll be solving today. Find the solution to the following initial value problem using Laplace transform. So this is the differential equation and these are the initial conditions. So we will be solving y prime prime minus 2y prime plus 2y equal to e to the negative t. Now, before we enter into the solution of these differential equations with initial condition y of 0 equal to 0 and y prime of 0 equal to 1. So you should recall that the Laplace transform of the variable y is equal to y of subscript s, and that of y prime is equal to s y of s minus y of 0, and that of y prime prime is equal to s square y of s minus s y of 0 minus y prime of 0. And the Laplace transform of the function e to the negative t is equal to the integral from 0 to infinity e to the negative st times e to the negative t dt. E to the negative t is this function. So this will result to the integral from 0 to infinity e to the negative outside. We will have s plus 1 all t dt. Now remember that the integral of this function e to the g of x is equal to 1 all over the derivative, that's g prime of x times e to the g of x. So if we apply this approach here, we will be having negative 1 all over s plus 1 e to the negative s plus 1 t from 0 to infinity. If we insert infinity into this function, it's going to result to 0, 0 minus, there is a negative here, 1 all over, we insert 0 here, we will have 1 at this part, so s plus 1. So the Laplace transform of e to the negative t will be equal to 1 all over s plus 1. Therefore, we can conclude that the Laplace transform of a function e alpha t e to the a negative t is equal to 1 all over s plus a. When you have negative here on the function, on your result you will be having plus, but when you have positive value for a here, on your result you will be having minus. So this is a standard equation to compute the Laplace transform of this type of functions. Now if we insert the Laplace transform of y prime, y prime prime, and e to the negative t into this differential equation, we will be having that of y prime prime will be s square y of s minus sy of 0 minus y prime of 0 minus, there is a 2 here, so we'll be having 2 into s y of s minus y of 0 plus this 2 y of s equal to 1 all over s plus 1. Now we will insert the initial condition s squared to the y of s minus s y of 0 is 0 minus y prime of 0 is 1, and we will be having 2s y of s plus 2y of 0 is 0 plus 2y of s equal to 1 all over s plus 1. Now y of s, y of s, y of s common, and negative 1 we can send it to the right hand side of this expression. So that will leave us with it's going to leave us with s square y of s minus 2s y of s plus 2y of s. This will be equal to 1 all over s plus 1 plus 1, this one. So we factor out y of s, we'll be having s square minus 2s plus 2 equal to, we do the algebra of this path, we will have this will give us s plus 1, 1 plus s plus 1, yeah, it will give us s plus 2 all over s plus 1. Therefore, y of s is equal to, we divide all through by this part. We'll be having s plus 2 all over s plus 1 into s squared minus 2s plus 2. So this is the function in S domain. Now remember, we are solving this initial value problem which has been given in time domain. So we have to transfer this function back to the time domain. Now by partial fraction, y of s can be written as a all over s plus 1, the first factor, plus, since this is a quadratic equation which cannot be factorized, we will be having bs plus c all over s squared minus 2s plus 2. So we will be having, we'll need to expand this term. So if we multiply all through by the denominator of y of s, this denominator will disappear on the respective parts, and this one will go to this numerator and this will come to this other numerator. So we will be having the numerator of y of s, which is s plus 1, s plus 2, equal to a into s squared minus 2s plus 2 plus bs plus c into s plus 1. So when we set s to be equal to -1, this term will result to 0. What are we going to have? We'll have -1 plus 2 equal to a into -1 squared minus 2 into -1 plus 2, so plus 0. This will leave us with 1 on the left hand side equal to a into -1 squared is 1, -2 times -1 will give us 2 plus 2. This implies that 1 is equal to 5a. Therefore, a is equal to 1 all over 5. So this is the value for a. Now, this is the value for a. Now, we go to this part and expand. So if we expand, we have s plus 2 is equal to a s squared minus 2as plus 2a plus bs squared, that's this times this, plus bs, that's this times this, plus cs, this times this, plus c. So if we compare the s squared term, there is no s squared term on the left hand side, so it therefore means we will have 0 is equal to as squared plus bs squared. This implies that we have a plus b to be equal to 0. Therefore, b is equal to -a. So b will be equal to -1 all over 5. Now, for constant term, for the constant term, we have a constant as c and we have a constant as 2a. On the left hand side, our constant is 2. So it means we have 2 is equal to 2a plus c. Therefore, c will be equal to 2 minus 2a, which will be 2 minus 2 into 1 all over 5, will result to 2 minus 2 all over 5. So if we do the fraction here, we'll be having 10 minus 2, which will be 8 all over 5. So c is equal to 8 all over 5. Therefore, the function y of s by partial fraction can be written as 1 all over 5 into s plus 1 minus b, negative. Now there is an s here. Do not omit the s. We are separating because there is a plus here. So we are separating the bs term from the c term. So we will be having s all over 5 into s square minus 2s plus 2 plus c, which is 8 all over 5 into s square minus 2s plus 2. Now y, this is it. Now y of t will be equal to the inverse Laplace transform of y of s. So we are going to be taking the inverse Laplace transform here. Now the inverse Laplace transform of 1 all over 5 into s plus 1 will give us 1 all over 5 e to the negative t. Negative because here is plus. And the inverse Laplace transform of 8 all over 5 into s squared minus 2s plus 2 s plus 2. Now, looking at your Laplace transform table, this denominator does not match anything on your Laplace transform table. So we can arrange this denominator, this one. Now we are going to test s minus 1 all squared plus 1 squared. So if you expand this, we are going to do that on a rough sheet of paper. S minus 1 all squared plus 1 squared will result to s minus 1 into s minus 1. So this will give us plus 1 squared. This will give s squared minus s plus 1. So we'll have s squared minus 2s plus 1 will be 2. So yeah, this is correct. This is just perfect. So since this denominator is the same here, it therefore means we'll have this same path for their denominators. Therefore, the inverse Laplace transform of 8 all over 5 into s minus 1 squared plus 1 squared is equal to, is the same as, we will be having something, we'll factorize 8 all over 5. This function is now the same as, we will have omega all over s minus a all squared plus omega squared. So this is the same formula. It therefore means the Laplace transform according to your Laplace transform table will be equal to 8 all over 5 e to the t sine t, because it's sine omega t, because omega is 1 and a is 1. So since it's negative here, is going to be plus on this part. I hope this part is clear. So same for, we will be having the inverse Laplace transform of s all over 5 into s minus 1 squared plus omega squared. Now this will be the same as 1 all over 5 into, we now have e to the t, because it's negative we have positive, all multiplied by cos t, cos omega t, omega is 1 t, plus we will be having now a all over omega. So a is 1, omega is 1, that will give us sine omega t, omega is still 1 t. So these are the inverse Laplace transform of the various terms we had. So if we compile them together, y of t will be equal to, we have 1 all over 5 e to the negative t minus, this is a negative here, remember this is for this. So if we expand this, we have 1 all over 5 e to the t cos t minus 1 all over 5 e to the t sin t plus 8 all over 5, this one, e to the t sin t. Sin t, sin t, e to the t, e to the t. So it means sin t, sin t, e to the t, e to the t means this term can be combined. So if we do that on a rough piece of paper, if we do negative 1 all over 5 plus 8 all over 5, we look for 5 as LCM. We have negative 1 plus 8, which will result to 7 all over 5. So that's going to be 7 all over 5. So y now, y of t can now be written as, we factor out 1 all over 5, then we will be having e to the negative t minus e to the t cos t plus 7e to the t sin t. So this is going to be the result of the initial value problem we were solving from the beginning. So this is the result to the problem we have been solving from the beginning. The problem goes, find the solution of the following initial value problem using Laplace transform. So this is the problem, and this is the solution. Please make sure you hit the notification bell such that whenever a video is being uploaded, you receive notifications. Like and